When the moon sits low on the horizon, it looks massive, yet hours later, when that exact same body is directly overhead, it appears significantly smaller. The physical size of the moon hasn't changed at all. Our brains are simply misinterpreting the distance because of the surrounding context of the horizon. Our own visual processing centers deceive us. Apply this same biological limitation to the entire night sky. If the cosmos were infinite in size and infinitely old, every line of sight would eventually hit a star. The night sky should be a blinding, unbroken sheet of white light. The blackness between the stars is actually a piece of profound evidence. The darkness exists because the universe has a finite age, and it is expanding so rapidly that light from the most distant stars simply hasn't had the time to reach us. We perceive reality through a strict biological filter. To understand the actual mechanics of the universe, we have to look past our immediate senses and rely entirely on the physics. When we trace that expansion backward, our math can only take us so far. We hit a mathematical wall at $10, negative 43 seconds after the Big Bang, a fraction of a second requiring a decimal point followed by 42 zeros. At this scale, known as Planck time in honor of quantum pioneer Max Planck, our current mathematical models collapse and space and time become governed by quantum mechanics we cannot yet fully resolve. In the moments immediately following this threshold, a high-energy conflict played out across the young cosmos. Matter and antimatter were created in almost equal amounts, instantly annihilating each other upon contact. This visualization displays the exact mathematical anomaly that allowed anything to survive. For every 1 billion particles of antimatter generated, there were exactly 1 billion and 1 particles of regular matter. The vast majority of matter and antimatter destroyed each other, leaving behind the energy we now detect as the cosmic microwave background. But that single leftover particle of regular matter per billion survived, cooling into the hydrogen and helium that fills space today. Every star, planet, and biological organism in existence is the direct result of that microscopic ancient statistical error. Out of those early hydrogen clouds emerged structures far larger than anything burning today. Quasi-stars, or black hole stars, were celestial giants that grew up to 10,000 times larger than our own Sunday. Rather than relying on nuclear fusion at their cores, these massive bodies generated immense energy from a central black hole that actively consumed the star's own internal gas. Because of their unique anatomy, they didn't erupt into brilliant supernovas when their fuel ran out. They simply collapsed inward, silently forming the supermassive black holes that now anchor modern galaxies. Since we cannot directly observe the birth of these ancient galaxies, astronomers measure their age by hunting for chemical fingerprints in their oldest stellar neighborhoods, specifically looking for a rare element called barium. Barium is forged very slowly through the collision of cosmic rays over immense stretches of time. By measuring its accumulation in distant globular clusters, researchers have a chemical clock that dates the Milky Way at over 13.4 billion years old. The universe's most massive early structures may have vanished from the visible spectrum entirely, but they left behind precise chemical and gravitational records we can still read today. That principle of hidden history applies directly to our closest planetary neighbors. From Earth, the Moon appears entirely static, a completely dead rock locked in our orbit. But instruments placed during the Apollo missions recorded hundreds of moonquakes, some reaching 5.8 on the Richter scale. The Moon's interior is still cooling, causing its outer crust to actively fracture and shrink over time. Further out, Mars presents another visual deception. Its current state as a frozen red desert is merely the aftermath of a catastrophic planetary collapse. Early in its life, Mars had a hot molten core that generated a strong magnetic field, but because the planet's radius is only half that of Earth's, that internal heat dissipated quickly, the core solidified, and the planet's magnetic shield collapsed. Without that protective barrier, high-speed solar winds bombarded the planet, stripping away its thick atmosphere and causing its oceans to boil off into space. To find evidence of what Mars used to be, robotic explorers like the Rosalind Franklin rover are designed to drill deep underground, searching for ancient biological spores shielded from billions of years of surface radiation. A planet's surface is rarely an accurate reflection of its past. The active geological history and any potential for life are always buried beneath what is essentially a planetary graveyard. Zooming out to the scale of the entire cosmos, we find the largest gap in our perception yet. Roughly 96% of the universe is made of dark matter and dark energy, both completely invisible to our eyes. Albert Einstein theorized a cosmological constant, a property of empty space itself. We now recognize this as dark energy, a fundamental force that is actively stretching the fabric of the cosmos. As more space is created, this energy compounds, pushing galaxies away from each other faster than the speed of light. Left unchecked, this expansion guarantees the universe will eventually become isolated, cold, and dark. In a universe governed by this constant decay, holding out on a single rocky planet is a mathematically doomed strategy. Earth cannot serve as a permanent sanctuary. Theoretical physicists like Stephen Hawking emphasized a stark reality. Human survival depends entirely on our ability to establish a permanent presence in deep space. To survive long-term outside our atmosphere, we have to engineer environments that mimic it. This means constructing massive ring-shaped stations that rotate continuously, using centrifugal force to precisely simulate Earth's gravity and protect human biology. Constructing architecture at that scale requires resources we cannot afford to launch from Earth. The necessary materials must be mined directly from passing asteroids, many of which contain trillions of dollars in raw iron, nickel, and platinum. We are born into a universe that actively hides its history and its decaying nature from our senses. But by applying the laws of physics and the tools of engineering, we have the capacity to pierce those illusions and construct our own permanent reality among the stars.